Hello everyone. In this video I'm going to speak about some applications on Brønsted-lowery acids and bases. Let's get started. Okay, so we have here a question: identify acid conjugate base pairs in the following reactions. So our first reaction here, we have HCl plus H2O is giving H3O positive, Cn negative. As we have said in the previous video, we have to check what has happened to each of the reactants. We have HCl. What has happened to HCl? As we can see here, HCl has lost or donated the proton, donated H positive. For that reason, we can say that HCl is acid. Why? Because it lost the proton. How I may know that? Simply by comparing it to its pair. As we said also in the previous video, when an acid is losing a proton H positive, it will become a conjugate base. So Cn negative is the conjugate base of HCN. What about the other reactant, H2O? What has happened to it? I have to check. Okay, it gained H positive. So this is a base and its pair is a conjugate acid. Let's check another example. Whatever the reactants, whatever the products, what we need to check is the proton transfer. What has happened here? Let's check. Where is it in the product? Okay, here is it. What has happened to it? It gained H positive. So this is a base. Its pair is a conjugate acid. This is its pair. HCl has lost H positive or lost the proton, so it's an acid. Its pair is a conjugate base. For that reason, we can say that the conjugate acid-base pair differ by a single proton. Why? As you can see here, what has happened to this base? It gained H positive. What has happened to this acid? It lost one single H positive. Let's check another question. The hydroxide ion, OH negative, is a Brønsted-lowery base, and the hydronium ion, H3O positive, is a Brønsted-lowery acid. Explain why they are not a conjugate acid-base pair. Let's study OH negative. But before that, we have again to remember that the difference or the single difference between acid and its conjugate base, or base and its conjugate acid, is a single proton. So if we're speaking about OH negative, they are already telling you in the problem, in the question, that OH negative is a base. So OH negative is a base. How it could be a base? It will be a base by gaining H positive. So it will become H2O, and this is the acid. This is its pair. This is its pair. Why? The difference between them is only H positive. So to make H2O, OH negative has to gain H positive. What about H3O positive? H3O positive is already an acid, telling you in the problem on the question it is an acid. So its conjugate base will be the difference between them is a single proton. So it is, here is the base. Okay, there is a very important thing here. OH negative, the difference between OH negative and H3O positive is not a single proton, is not a single proton. Why? Because if I add the proton here, after adding a proton here, it will become H2O. It still needs another proton, so I have to add another proton here to make it H3O positive. For that reason, OH negative and H3O positive are not a conjugate acid-base pair because they differ by two protons, not a single proton.